Hey everybody, this is Dr. A, and in this video we are going to be exploring a third example of solving equation systems by substitution. So let's go ahead and take a look at our given information. You want to take some time, write this down. Remember, the best way to learn math-based material is to write it down and do it along with me. So our given information says solve the system using substitution. And we have our two equations. We have a system of two equations with two variables. Our first equation is x plus y equals 3, and our second equation is negative 2x minus 2y equals negative 6. So if you want, just to be organized, we can label these equations, equation 1 and equation 2, just to kind of keep them straight in our heads. And we're going to go ahead and write solution here. So as we discussed in one of our previous videos, in order to use the substitution method, you solve for one of your two variables in terms of the other variable within one of the equations, and then you substitute that into the other equation. It does not matter which variable you choose to solve for, and it does not matter what equation you start with. So if I were you, I would just start with something that seems pretty convenient for you, okay? Now, one thing that you can notice about this particular system of equations is if you look really carefully at equation 2 here, you see that equation 2 is actually just a simple multiple of equation 1. Let's write that out and explore that a little bit further before we actually get into using the substitution method. So rewriting equation 2 here, we can factor out a negative 2 from every term on both sides of this equation. So I'm going to factor out a negative 2. I'm going to open up a parentheses and I'm going to be left with x plus y in these parentheses equals negative 2 times 3, okay? So again, on the left-hand side, I factored out a negative 2 from both terms, and so I was left with negative 2 times the quantity x plus y equals, and then instead of writing the negative 6 over again, I wrote that as negative 2 times 3. And with that, we can see that we create a convenient cancellation with these negative 2's. So equation 2 ends up being simplified to x plus y equals 3. Now, if you notice, this is identical to equation 1, okay? Now, anytime you have a system of two equations that are completely identical to each other, the solution to that system will be infinitely many solutions, okay? You won't have one unique solution. You're going to have infinite solutions. So we can go ahead and state that right now. We can say since equation 1 and 2 are the same, they're identical equations, we have infinite solutions. And of course, the system is consistent. Now, that's good enough to be your final answer. That's good enough. However, if you don't recognize this, okay, let's say that you did not recognize that equation 2 was just a multiple of equation 1. That's okay. It's not the end of the world. If you don't recognize that, then you can just proceed as you would if you didn't recognize that. So let's write that down. Let's say we did not recognize, spell that correctly, recognize that 2 is a multiple of 1. What I mean by that, equation 2 is a multiple of equation 1. That's okay. So let's go back and start with equation 1. Equation 1 is x plus y equals 3, and equation 2 is negative 2. Let's color coordinate properly. Equation 2 is negative 2x minus 2y equals negative 6. Well, let's just proceed as if we didn't recognize that 2 was a multiple of 1. So we can rewrite equation 1 by solving for one variable in terms of the other. Let's just be different this time and say y equals negative x plus 3. So notice I'm taking equation 1. I'm solving for the variable y in terms of x. And then I'm going to substitute into equation 2. And what happens when we substitute that into equation 2? Equation 2 becomes the following. We'll have minus 2x minus 2y, but y is equal to negative x plus 3. And then, of course, all that equals negative 6. And we will simplify this, so we'll have negative 2x plus 2x minus 6 equals negative 6. So notice here I distributed this negative 2, and that's how I ended up with the positive 2x and the minus 6 here. And so if you look carefully here, you see minus 2 and positive 2 cancel, and you're left with negative 6 equals negative 6, okay? Whenever you have a term equaling exactly the other term, or in this case, a constant equaling itself, then that is still an indication that you have infinitely many solutions. So when an equation simplifies to a constant equaling itself, then we have infinite solutions, okay? Again, you have the same equation repeated twice. So if you were to graph these, for example, their lines would just lie right on top of each other, and they would be intersecting infinitely. So that's another way of thinking about it. So that concludes this video on solving a system of equations with two equations, two unknowns, where you end up with infinitely many solutions. Thanks for watching. Please hit like and subscribe.